Yeah, who all are left? Both of you.
Rohan, Reliance.
Okay. So, I'll be taking a physics class, and today we'll be starting with light chapter, light reflection and refraction. Okay. Have your school started? I believe yes. A part of it. And has this chapter started in your school?
Yes.
Oh, great. So, we are also starting with this chapter. In case for the next, after finishing this, if there is a kind of pattern in which chapters are done, not in if any random chapters are being done in your schools, do let me know so that we can also go in the same order. Do it before then, if time permits. So we will start with light, and majority of you would know what light is and some part of that because it is already done in your school. Can you quickly tell me what is light in physics term or layman terms, whatever you know? Yes, you please.
Light is a form of energy.
Okay, can you add to it? What else do you know about light?
Light is made up of photons.
Okay, okay, great. Does anybody know what photon is? Not proton. He said photon. That is different thing, not proton. Okay. Yes. What else do you want to add?
It travels at the speed of 3 into 10 to the power 8.
Yes, it's 3 to 10 to the power 8 meter per second. That's the speed. It's actually energy, and it travels with that speed. Anything else that one would like? Yes, please.
We can see because of light. We can see because of light.
Yes, you can see because of light. Very true. And do you know we can see because of lights, certain thing that happens and because of which we see. What is that? Reflection. If it was not reflecting, we could not have seen it. Okay, so reflection makes things visible to us. Reflection of light makes things visible to us. And in reflection, I want a quick recap of whatever you know with respect to reflection, with respect to plane mirrors, because in this chapter, as you know, we'll be studying about concave, convex, or those curved mirrors. But we already know about plane mirrors, right? So tell me, and this means this is not the painted part, not the, this is not the polished surface, the reflecting surface is this, so this is not the polished surface. Here, from this side, light will hit. It's clear. Is it visible to you, the green marker? So for plane mirrors, we know reflection of light follows some laws. So this ray is hitting this plane mirror. What do we call this ray? It is incident ray, and we know that it is going to be reflected, and we call this ray.
Ray of reflection.
Yeah, reflected ray of reflection. But I drew it like this. Can I draw this as reflected ray? No? No? Everybody thinks no. Can it not be reflected in that direction?
Is the direction of the incident ray the same?
You tell me, like I have given you everything
No.
that is required. This is possible. No, he is raising hand. Do you have a reason behind this? Why this is no? Yes, please tell me.
Because angle of incidence and angle.
Because we have to stick to the laws of reflection. What does law of reflection? Laws of reflection say that this is plane surface. There is normal to it. Let's draw that imaginary normal line. What is normal? A perpendicular line to the plane surface. Okay, and of course it is not that accurate because I am drawing it with my hand. So the laws of reflection say that this incident angle has to be equal to reflected angle. Please, if here, of course it is not equal, but that's because of my drawing. Certainly this makes it very clear that if this was your reflected ray, the angle is certainly not the same. So you cannot just reflect it anywhere as per your wishes. It has to follow the law of reflection, which says incident angle has to be equal to reflected angle. Very important law. And of course they all are on the same plane, the reflected incident and the normal line. With this, let's jump to the second simple question that I'll ask and to the major part. In mirrors, all that, like why do we need a mirror? What do you do with mirror? Do you play with mirror?
No.
What do we, like why do we need a mirror? What exactly do you use it for? To see ourselves, to see the image. So mirrors is all about images. Okay. So when I do anything and what I study with mirrors is, where is the image formed? How is the image? Okay. In plane mirror, if I am standing here, the plane mirror is 4 meters away from me. Okay. Can you tell me how far my image would be from me?
8 meters.
My question. Yeah, the image would be 8 meters away from me because the image is 4 meters behind the mirror. So in all, it is how much away from me? 8 meters. Is this clear to everybody? Is this clear to everybody? So this was a plane mirror. It was pretty easy. That okay, 4 meters away, behind it will be formed and it's 4 meters away. The second thing is how big or small it is. What will be my image size in plane mirror? Can you tell me? If I am like 5 feet, how long will be my image? 5 feet. It's exactly same. There's no difference with that also. Plane mirrors is pretty easy, but that's not the case with curved mirrors, which we are going to study. All we are going to study is those two types of curved mirrors. I presume you already know the names, but the major thing that we are going to do is where will be the image formed using the only thing that helps is ray diagrams. All I want, like I don't want to repeat this in any next class. After this, if we are drawing any ray diagrams, make sure you have a sharpened pencil. You use a ruler. If you do not have ruler today, borrow it. But from next class, do bring a ruler. You need a sharpened pencil. Please carry an eraser as well. You use pencil for these diagrams. Is that clear? And of course, please have a book. Do not use your volumes. Okay. Let's start with the curved mirrors. Curved, as the name suggests, they are curved. There's a bend to the shape of that mirror, and it is said that to make it easier in physics understanding, we say that curved mirrors, like this mirrors, are part of some spherical. Let's presume that it's part of some sphere. We cut it, so we get this part. It is up to me now which part. What happened? Okay. Like, not jump for it because I'll say when to draw ray diagrams. You can ask for that at that time. So it is up to me. It's like you know. As of now, of course, if you play football, I'm saying, even if you play football, that's fine. If you play cricket or football, if you cut it, I know football will completely, but you do not use those proper the cricketers ball use करते हैं क्या बोलते हैं सीजन बॉल तो नहीं हम use करते हैं यहाँ की गली क्रिकेट में what do we use some rubber balls if you cut it will have this curve shape like this. Now it is up to you which part do you want to paint, like paint in the sense the silver करना है surface को reflecting surface बनाना. You can either paint the inner surface or you can paint the outer surface. Okay, if I paint the inner surface and not the outer surface, then I am painting a cave, right? It's like a cave and I enter and I see a cave in somewhere. So these kind of mirror where inner curved shaped surface is painted, we call, or that is the reflecting surface, we call this concave mirror. These are concave. What will be convex then? Instead of painting the under the part, I paint which part? I paint the outer portion. Okay, it's like spoon. If I refer the inner surface, that is which mirror? Concave. And if I refer the outer one, it is which mirror? Convex. We have some different names to these when it comes to examination. Of course, the ones who set paper are not that. They sometimes tend to confuse students. In case students are already confused, otherwise nobody get confused. So they, instead of using concave mirror, they'll use some other name. like converging mirrors or diverging mirrors. So why, what is converging, what is diverging, will come to that. But this part, at least when they say concave mirror, henceforth if somebody is asking you to draw a concave mirror, you should not get confused and draw this mirror. Okay? It should be very clear from now that if the word cave comes, that means the inside surface is reflecting. Is that clear? Now we'll move to why the names converging and diverging. Yes, please.
It is called converging as the rays converge towards the focus, and
Yes.
divergent as they
Ray diverge. So most of you know. Let's quickly finish that and go to ray diagrams then. So for that we need to know few terminologies. So we know that this concave or convex mirror are part of some sphere. So that is why we use. So we have some reference geometric terms that we use for our ray diagrams. This is what center of the curvature of which we used to make that mirror. So we represent it by C. But then we don't have this whole mirror, right? It's not that usually, it's just a cut part. So if this mirror looks like this, like the bent portion, then the mirror ka jo center hai, what will we call that center as? We'll call that pole. That's the center of the mirror. And if we draw one axis, then this will become what? Principal axis. That is principal axis. Okay. And like he said, what's your name, Pita? Like Atharva said, that if, let's say, rays are coming from sun, and when I guess you were in 5th grade or maybe in some videos you must have seen, for those cooking solar cooker experiments, what do you use? You see that rays, sun ki jo sari dhoop hoti hai, bahar hum rakh dete kadi dhoop mein, the rays fall, and where is that pot kept, the bartan jis par khana pakne wala, where do you keep it? It's at the center and somewhat away from that curved shape. Actually we use concave mirror for that. So it is like this, rays hit and the bartan is kept somewhere over here. And why is that so? Like, because like Atharva said, when rays hit, they actually converge and all that heat gets concentrated at one point, which is called focus. So what is happening, all those rays, since they are coming quite far away, they are coming quite far away, they are coming from far away, so they are parallel, and they all, after hitting the mirror, where will it go? Will it go that side? Of course, it's mirror. So they will come, it will reflect, and we have certain points. We have something called C, and half of that in some cases. Which are those cases we'll discuss, but as of now, remember, if you draw 2 centimeters away is your focus, then actually 4 centimeter away is your center of curvature. Basically, focus is half of center of curvature. In some cases, which are those cases which we'll discuss further why and what, but as of now, let's stick to this. So what happens, all these rays, they all focus, they bend towards one single point, and that is focus. That is called what? Focus. In case of your convex mirror, again parallel rays will hit. Okay? And what will happen now? They will diverge. Instead of moving closer, no, in this cases they move away. This will go back, they move away. But then it seems that they all are coming from behind the mirror from some common point. And that point is again called what? Focus. here is the answer to our question. Can you tell me now which of this mirror is converging mirror and which one of this is diverging
The
mirror?
left one is the
Converging mirror and the right one is. Now can you not use left one and right one? Can you use which mirror is diverging and which mirror is converging?
like the rays are
No, the name of the mirror.
yeah, the concave mirror is the converging and
And the convex mirror is
diverging.
diverging. So now we are actually moving to a major economy in the ray diagram. Then all we do is where the image is formed, how does it look, that's what we are going to do now. Rays, okay, we'll discuss it this way. For that sun rays were moving quite far away. They are coming from far away. They hit the mirror. They come together, and we have that patila to patila. But in some cases, if people also keep paper to take the image of sun. Have you seen those videos or something like that? Okay. Let's not get into that. We'll discuss why I was asking this question. This is concave mirror. We will be seeing. We keep one object over here. Okay. All I want to find is where is the object's image formed. But for that I need to know some more things about that. To find out image location, we need one specific thing. We need to find where do those rays meet. What I mean by where do those rays meet is, if I want to find image of this tip, and throughout the day from sun, thousands of rays would be hitting at different angles at this point. Yes or no? Yes. They would be then getting reflected in some other directions. Yes or no? And those rays would be hitting this mirror. Yes or no? What I want to know is, where is my image formed? So we are not concerned about what hits, because sun is any which way is giving ample amount of light. So let's say there are thousands of rays falling on this every second. And from this point, those rays get reflected. Let's say one goes here, another goes here, another goes like this. Okay. Then, since this is mirror, they will get reflected in some or the other direction somewhere. It will get reflected. And what we need to find is where after reflection, these rays would meet. Okay. Because that meeting point of reflected rays decide where the image is of this point. Did you get the point? The rays coming from this tip hits the mirror, then it has to meet somewhere, right? Because after meeting, that is, what is the meeting point? That is actually the image of this point. To find the intersection point, how many minimum rays do you need? We need 2 minimum rays to find an intersection point. So while drawing these ray diagrams, we have certain laws like we had for our plane mirrors. We use those laws and then find the location of the image. The first law says, this is pole, this is focus, this is center. Okay, let's say my object is somewhere. The first law says that if a ray is hitting the mirror, this would be for the object also. If the ray is hitting the mirror after reflection, if this ray is parallel to the principal axis after reflection, can you tell me? I know you know, but this is done in your school, right? Can you tell me?
Yes.
Okay, the ones, yeah, please tell me. it will pass through focus. So first I write this side because we will use this law every time. If it is parallel, then after reflection it will pass through focus. This is parallel side. Okay, I do not get confused. So after reflection, I will use another marker. After reflection, it has to pass through focus. That's the first condition. For what happened? For the second case, is it done in your school? The one, okay. For this, you answer. Let's say that ray is passing from focus. Let's say that ray is passing from focus. What will happen after reflection?
Parallel to the principal axis.
It's just the opposite of the earlier. So the after reflection, it has to be parallel. Okay. So if it is passing through focus, then after reflection it has to pass through focus. The third one, yes, I think both of you have answered. Yes, what's the third one?
If it passes to the center of curvature, it will reflect back the same time.
Yes, that's the most easiest one and the least used also in ray diagrams. So the last one is if it passes through, let's say it is passing through your focus. It's passing through your center of curvature. What will happen? It will trace back. It will go back. What was my reflected rays direction? It was red color, so it will trace back. Okay. The last one is which everybody knows. Who will tell me? The fourth one. Yes, please.
It goes like it's a pole and it reflects back.
Yes, the last one is which we all know because it's actually the plane mirror because it's the law of reflection. It will work over here also. What's the last one? It says if it hits the mirror, we know if it hits the mirror at pole that too, then it has to reflect at the same angle. If this is I, angle of incidence, then the reflection I, the reflected angle R is actually equal to I. So both of them are same. Why is this so? Because it is hitting the mirror and it has to follow laws of reflection. Angle of incidence is equal to angle of reflection. This is least used one. We use the first two rays quite a lot to find the image location. Yes. Now we will start with the first case. Please draw concave mirror. Please draw your center of curvature at a distance which is permitted in your book. You cannot go beyond 15-20 centimeter, I guess. So let's say you are doing 4 centimeter. Then mark focus at 2 centimeter. It's up to you. You can make it 3 if you have more space in your book. Draw an object which is an arrow beyond C, because we are starting with beyond C. I want you to draw an object which is actually an arrow beyond C. And we did something, we saw the 3 laws. So I have got written the 4 is laws of reflection. I'm just passing through C and facing back. What was the 4th one? Hitting at P and I is equal to angle R. So what you have to do is you have to draw some object beyond C. If your drawing is 2 centimeter, 4 centimeter, you can put this at 5, anywhere after 4 centimeter. Use this tip, draw 2 rays using any of this, it's up to you. Draw 2 rays. Why 2? Because you told me that we need at least 2 rays to find the intersection point. And show me where's the intersection point. Use any of these two. I would recommend you to use the first two. Even third one is fine. Don't go for this one. You will have to use protractor then to find angle 1, angle 2. Please use the tip. Draw 2 rays. We will check if your answer would be as mine. But it cannot go wrong because answer is already given. Use any of the two. Yes, you have any questions? I said do not use volume. You came to mathematics class without I can understand physics. What did you do previously?
How much distance is the object behind inside the corridor?
I said draw it anywhere beyond C. It's up to you. You can make it at 5, you can make it at 4.5, you can put it at 7 if you have space. Yes. What did you do in math class? Next one, this is not allowed. Either we can have a discussion with our director or speak to Anubhav sir, okay? So next time, make sure you have a book, even for other classes. Draw it and at least use a pencil. You can ask somebody. What happened?
Not a set square.
A scale, right?
You do not have any other thing. You can use anything. Why do you want set square?
Because he has the scale.
It's okay. It's okay. You can use edge of your book in times of crisis. You done?
Right.
Good. Equation is good, right? Use this Laplace this class gets over at 6:20. Are you done? Yes. Are you done?
Still, I forgot the law.
But I have written all the 4 words. Yes. Base, the wind base. So this point is your image of this is shifting. Okay. The laws are correct. Please make sure when you are following the laws, what did I say? You have which image are we looking for? The tip point, right? So rays will move from which point? It has to move from this point and hit, right? So did you get where you went from? Your rays are not coming from here. So your rays, if one ray is one side this, the other ray just cross. Please read what it is. Otherwise you will write. You understood the laws very well. Is this yours?
Yeah.
Okay. Is this the diagram? Is this diagram or the previous one? Okay. Did you understand the question? Yeah. So first draw another one. First draw a concave mirror. Draw a principal axis. Okay. First do that much. Then come to me. Okay. Great. Okay. We'll discuss this part when I explain you. So one ray is moving from this way, which you are moving, that is coming looking somewhere else. So that image will be of some other thing. Are we looking for that light which doesn't give image of this? So the other way also has to pass from this. We this go somewhere. And this doesn't look same. This certainly doesn't look same. What did I say? This is 2 centimeters. This certainly looks more than that. Please use scale or at least good reference. You use or some proper reference other than yeah. We'll discuss this. You should not end it over here. Let the day go now. Let the day go. How did you do this time? At this time. Let it go ahead. Let the rays go, Baba. You need an intersection point, so it's okay if it goes up. Are you done? Are you done?
Yes, I got one.
One ray? You have to use 2 rays for intersection. Which ray are you? Which law of this did you use? Which one?
Focus and parallel.
Okay. Come closer, you can move here. Did you make sure this is equal to this? This looks slightly more than this looks like 1 centimeter, but this is more than that. It will give you, otherwise it is actually give you to the yes, good, that's right. You have used second and third, I guess. Yes. Good, that's correct. You use ruler, but it doesn't seem clear when you see it. Maybe it will be shine. Otherwise, it looks very yes. Who all are left? Okay, good. This has to be equal. This is 1 centimeter, and this would be somewhere here, I guess. And then one ray is passing. What is the first law saying? It is parallel. After reflection, it will move from C. Where will it move? L. So it has to use from
Center of origin.
what was the second one? The same point, there will be another ray which passes through and hits the mirror. We stop at the mirror. Then it becomes parallel. There are the lyrics. Okay, we'll discuss. I'll check yours. What is his name? Yeah, what are you? Aryaman, I'll check yours. After discussing, how did you draw that one? These two. Which? Did you use protractor? Okay, okay, let's see. Okay, please stop. It's okay, Aryaman and everybody. You better draw something, like even in your volume. So, the 2-3 errors that some people did, we'll discuss that first. What did I say? What I said was, please, I want image of the tip point, right? So, whichever 2 rays you choose, they have to start from that tip. Let's say I drew first on parallel and then focus. It has to start from here. It is parallel. It cannot start from somewhere else because I am looking for image of that tip. It cannot start from somewhere else. Okay. So first thing is it has to start from that tip point. So first one was parallel. After reflection, I use your. I use this. After reflection, it will pass through what? It will pass through focus. It will pass through focus. Okay. What was the second one now? Second one. So hitting a pole at angle, I would anytime ask you to avoid it. Why? Let's say I am drawing one ray. It reaches here. I have to actually measure that angle. How will I measure that angle? I have to use a protractor.
The angle needs to be precise.
Yeah, it has to be precise because even a small measurement error will from this to this, and image can be enlarged or diminished or whatever. So let's avoid this one as much as we can. If you are drawing, it's okay. Make sure everything is accurate. Use a protractor. Check what is the angle. Make same angle over here and draw it. It's up to you.
We have to find the point of intersection.
Yes, that's the thing that we are looking at. We want. What are we looking at? I want to see where my reflected rays meet. I want to know where my reflected rays meet. My reflected rays are in black color now. The second ray, I can choose this one also. This passing through C is also the easiest one. I'll draw one ray which passes through C. Let's say it passes through C. It will pass through C. And actually I found that it is meeting here. Why I am saying it is meeting here? Because after reflection also it will trace back the same path, right? So after reflection as well, it will trace back the same point. Let's check whether the third ray also passes somewhat closer, although my measurements were not that accurate, but hopefully it should be somewhere closer to this point. What was the third one? It has to pass through focus. Let's again, it should start from where the image point should start from the object point. So my object is this, the tip. It will, okay, I'm using black color for reflected rays. So it is hitting focus and meeting somewhere over here. After reflection, what will happen? It will become parallel. So it will become parallel. It has to go somewhere over here. My dimensions, my measurements were not accurate. Otherwise, it meets at the same point. It would be like this. You can check this in your diagram as well. The ones who could not do it can do this again now. Take any of the two rays, either this one, or this one, or the center of curvature one. The others would do the same thing for the other case. Now your object is at C. Your object is at C. Please tell me where is the image form. Is the second one. The object is at C. What did I say? Yeah, draw. What did I say? Okay. Yes. Correct. Second one here. And next one, make sure it is more neat than this one. Yes, the other one is at C now, right? No, we are doing the first one. Finish this one, then we will go for the next one. You're done? Okay, you can also do first. Okay, I did this one. Beyond C, looks right. Yes, correct. So it's the intersection point. So image is what? This is the tip, right? Yes, it's correct. Yes, no arrows because it shows this. Yes, or this one and this one. This, where is the intersection point? For reflected ray is this one. So your image would be what? This is the this point's image. Tip. Base is already on Go for the next one now. Object is at C. This one is the most easiest one. This should not take much time. Are you done? Yes. Okay.
done.
We'll be drawing one more after this. We need to see something. What I want you to check is something with respect to that. You must have gone somewhere wrong. Integration is that is right. It was certainly beyond the distinct. Otherwise, it has to be exactly at the same. Let me see there. The error is. This is 2. This is still focus. Can you draw it again? What's use sharpen it again and draw it. That? Okay. No, no. Everything happens. We'll see. Okay. Yes. Where? Show me. Now, the ones who have drawn it and why the tip is above? This intersection point is called tip or the case. Okay, it's done. This is the first one. This one. This is correct. This is the second one. We are about to learn a big thing because majority of them has gone wrong. So somewhere all of you are going wrong. Please see where. It's already done in your classes. Please check when object is at center of curvature. Where is the image formed?
It is supposed to be under it.
So why are you not getting it correct?
Because
I have taken every measurement.
No, so you are going wrong. So but think.
Object beyond it is.
Object height.
How can object height do something to the location of image? It will do something to the height of image, magnification part. I am quite happy that you all made that error. Apart from one, as of now found that has got it correct, but certainly you do not know why you got it correct and they did not get it correct. Okay, we'll discuss this and we'll learn the biggest error that almost everybody, including him, made. Beta, it's okay. You're not the only one in that boat. Shall we discuss now? It's quite important. So the first thing is let's go to the laws. One thing that I have to make sure is whether my object is straight or not, because if I draw like this and C is here and tip is here, then I can go wrong. But everybody was right on this thing, so do not worry. You drew a straight line of image. Okay? What was the first thing? This I'll do quickly. I'll not discuss over this. Most of you chose this as first parallel line, and then it passes through focus. The second ray that you chose from this one was the ulta of that. You chose this one, and it passes through that. Okay. What happened to most of you was some understood, because textbook says if the object is at center of curvature, your image should also be at center of curvature in inverted. So I got an inverted image, that's fine. But I did not get it somewhere here. It's understood in my case because everything right from this, that, everything is inaccurate. So at least you understand how much accuracy plays a role. Everything goes wrong. So most of you also got it over here. So something is inaccurate. Although you used ruler, you made sure everything was sharpened. Where are you going wrong? Did anybody understand where you went wrong? No? Okay. Yeah.
Also equal distances on
Which
the parallel
one?
lines.
It doesn't matter. How can it be equal every time? It's not. If my location is somewhere else, then it can be somewhere else. It's fine. No. The most important thing that was missing in your case was whether your pole was at the center of the mirror. Most important apart from that was whether it was proper concave mirror. It plays quite important role in that case as well. So what you do now, if you have a good, you already have compass, use that plus use center point of that ray or the center point of the circle which you used to make the circle half arc, and then pass your principal axis properly. Try to redraw it.
After I did that, it's still behind.
It's still behind. How much behind from the previous one? Previous one was very sharp. Give me the. Give me your. Okay, we have very. We do not have much time left. We'll discuss this. Yes, yes, she got it accurately. Yes. Okay, the ones who did not got it right, there's a huge hint coming. And the ones who got it right should also see. Please check their books and see what is the shape of the lens. We will now understand why initially I told you that you have to use C. Focus is half of C in some cases. What are those some cases? Understand. Please check the ones who are getting it at the C. There's some shape difference in what you do and what they are doing. Please check. He also got it correct. She got it correct. Please check the shape of. Did I say lens? Because I tend to use lens word. Shape of mirror, curved mirror. Did you see it? Okay, the answer is their curve portion is not quite curved. Yours is a huge curve. It's a huge bend. They have just drawn it. It's a very subtle curve. That's the answer. So you cannot draw it like this and expect that rule which said, that is I was coming to this. What was the rule? What was the rule? Rule in the sense, the first thing I said, focus is half of center of curvature, the radius part. In some cases I told it many times, you cannot take a quite curve and then get this answers. It cannot come here. Now draw a subtle curve and please try to find the answer. Do not take R more. Huh? What?
Still a bit.
What? So you can't see the improvement. You see this one. You see this one.
I just did that.
Oh. No. Still, this one was here, right? Where is it in the previous case? Where was your? It was here. It was
The
here.
center of curvature was here. So this was actually closer.
What did you take?
Nothing.
So that is why I thought it was the previous Change? No, but change. You already got the answer from them. Okay. Please make sure you ace the ray diagrams because you will be questioned on this. Drawing ray diagrams. It's good that you found, and this can happen to you during examination. It's better that you got to know about this because of them. So, good. Are you done? You got that correct? Okay, shall we do this next thing quickly? You can do this and ace this for next class. I know you know the proper shape of the curve which is to be used. Boys, let's stop over here. Please, let's stop. You can do it. It's a good homework now. Devising proper shape of the mirror. Okay, so what I want you to tell me, because we do not have much time left. We saw two mirrors now, right? I wanted to give you more tough questions, but as homework, saying this, I will. Let's quickly discuss where we use these mirrors. I know that you already know, but let's see if you can answer them correctly. It's done in your class. Huh?
Car side view mirror.
Car side view mirror.
I got it.
Yeah.
Anchor.
This is not done in your school, right?
It has started.
It has started. Okay, great. Shh. Over here. He says that these curved mirrors are used in rear view, the car's rear view mirror. Which kind of mirror do you think they are using? Concave or convex?
Concave.
Concave. Okay. Wait. Do you think he's correct? It's concave mirror? No. Then what it is? It's convex. Okay. I'll ask why to all of you.
Because convex gives larger area and it gives diminished. That's why for review it is better.
Okay.
Same.
Okay. Why I am discussing this is, if this happens during examination and you get confused, please remember the logic and what final logic we conclude for the right answer. Do you have any sides with the convex or concave? Convex. What's the reason? Same. Larger view, smaller image here. Same. Convex. Same. Convex. Okay. Everybody is saying convex mirror. Okay. So now another hint is coming. The logic was, he says, there is this curved, of course, in the parking lots and all those places, you see a proper curved mirrors like this over there, and you see wider view of the parking lot, or everything appears smaller. That logic is correct. For convex mirror, like for this convex mirror, you see a wider view and you see diminished smaller images. Okay, that's parking lot thing. He says that same logic is applied in rear view mirror. In rear view mirror, I don't know if you have read it in the mirror. Many of you objects are closer than. In this case, it is ulta, na? Object appears farther and smaller than. Do you see? So which mirror would that be? Which mirror would that be?
Is it concave or convex?
I am telling you the answer. You are not giving me
It's
the answer.
concave.
It's concave. Did you understand the logic? Why did I discuss all these things? Over here, please remember. Where else are we using concave mirror? Which is very easy. Where do we use concave mirror? Where we want larger image, like your teeth, then we need. So wherever you need an enlarged image, you will use which mirror? Concave. Wherever you want a wider view and smaller images are fine, you will use what? Convex. Is that clear? Yes. That's lens. Great. Okay. So let's quickly have a recap. I think time is done. 6:20. No, we have 3 minutes. Over here, we'll start with you, please. Tell me what is focus.
The point where it intersects.
What intersects? It intersects. Which rays?
Reflected rays.
Okay. What is focus of converging mirror?
When the rays converge. reflected rays conversion.
Okay. Which mirror is converging mirror?
Concave.
Okay. I actually wanted to discuss something. Okay. Before we have 3 minutes, we can quickly discuss. In plane mirror, my image is found behind the mirror. We use one word like virtual image or real image. What is that image? Virtual image,
is
right?
formed behind the mirror.
It's formed behind the mirror. And real image is what
Form
that?
on the, if you keep something in front of it, it will form on
The
the.
rays converge.
Is upside down.
The point where the rays converge. So if you keep a screen at the focus, so the image will be visible there.
So basically we are saying that it is found in front of mirror. If you place a screen, in case of real images, you can form image over there. Can you now answer in this the images that you formed in your concave mirror things? Is this real or
Real.
virtual?
Real.
Yes.
It's real. Okay. Why it's in front of mirror? But what the actual concept of definition of real and virtual is? Yes.
Actual lights are intersecting.
Yes. So if after reflection in reality those points meet, then we say it is a real image. But if it doesn't meet and it is formed, still image is formed because it is seen that it is coming from behind the mirror. The rays are coming from behind the mirror. They are meeting behind the mirror. But are they really meeting behind the mirror? Can they meet? No. So that is why what are real images? Where rays meet, the reflected rays meet after reflection. And the other one, virtual one, they do not meet in reality. You are done. I don't think so. I need to ask some questions. What is pole? Yes, please. What is pole?
The principal axis.
The definition of principal axis is pole and center of curvature. And also, what is pole?
Center of the
Yes,
concave mirror or
center of the mirror surface. So center of the mirror. What I'm saying is yes. Okay. Can you tell me? We had like 4 rays which can be used to find the image. Can you tell me one ray, like the law which we use?
If a ray is parallel to the principal axis, then it gets reflected back from the focus.
Okay. Can you say the other one? It passes to focus and is parallel to the principal axis. If it passes through focus, it is parallel to the principal axis. Can you tell me the third one? Can you tell me the fourth one? When it hits at what point? Yeah, if the ray hits the pole, then it gives the angle of incidence is equal to angle of reflection. Yes, thank you very much. What up? Okay, but the homework part, okay. So this of course is one homework. Since I think we'll be meeting in next week, you'll have ample amount of time to do brainstorming. This, please listen to this. You do mistakes here, it's fine, you will learn, at least you won't do this in examination. Others' mistake and your mistake. The homework is very important. Instead of concave mirror, I want you, this is really extra one, it might take a lot of brainstorming, provided you do not do something on your own first and then refer Google. So, use convex mirror, and I want to know where the image is formed, again in the case where object is beyond C. But in this case, the mirror is changed. Which is the mirror now?
convex mirror.
I am giving you already a hint. Yes.
It seemed to be intersecting.
Yes. So good. He said focus. So you already know in case of which mirror? Convex mirror. Where is my focus? Here or here? So please now use your laws and whatever, but do not draw your focus here without. Just don't go blindly. Okay, the hint is here. All the best and thank you for the class.
पार्टिकल्स जितना लेकिन लाइट तो एक
मतलब ऐसा थियरी ना क्वांटम थियरी ऑफ लाइट इसमें वो वेवलेंथ ट्रैवल करती है
ऐसा आधा का पढ़ के इस क्वेश्चन
अरे so called traveling wave and इंटरेस्टिंग बात क्या इसके दोनों है ना जो पहले होते हैं ये दो थियरी बदलती है देखते हैं हां पता है मुझे
गूगल से आता है पढ़ गूगल है की पढ़ाई तो मतलब कि गूगल से पढ़
क्वांटम फिजिक्स क्वांटम फिजिक्स आई बोलते होते चीजें आकर भूल गए ले
पार्टिकल्स लाइट
लेक्चर स्टार्ट हो गया तो फिर मैं
दिया ही नहीं अरे धीरे थोड़ा दिखा अरे हाथ में नहीं
मार के ना
हां बात कर से
मैंने बोल उसके आप लोग एक्सीलेंट
लेक्चर को तो बहुत